Hey guys, today we're doing Chapter 4, Section 4, which is on identities involving sine, cosine, and tangent functions. So an identity is an equation that's true for all values of the variables for which the expression is defined. In other words, an identity is always true. So it would be something like x equals x, that's always true. Or 3 equals 3, that's always true as well. So something that's equal to itself is always going to be considered an identity. Basically, when you have two things that are equal and they're always equal, that's considered an identity. For example, one that we've talked about recently would be conversion rates. So like 1 foot equals 12 inches. That's always true. That's an identity. Okay, so our first identity is the Pythagorean identity. And that says cosine squared plus sine squared equals 1. Now, you'll notice that that's actually just based off of the Pythagorean theorem. If I look at the unit circle, remember that the radius of the unit circle is 1. So let's say I'm looking at this point here. This point here is going to be cosine theta, comma, sine theta, where this side is 1. So my x value is cosine, my y value is sine. Well, this creates a right triangle where my hypotenuse is 1. So that shows me that sine squared theta plus cosine squared theta equals 1, according to the Pythagorean theorem. So using the Pythagorean identity is actually really easy. If I know that the cosine of theta is 3/5, and I want to find the sine of theta, well, I can just replace the cosine of theta in this equation with 3/5. So I have 3/5 squared plus the sine squared theta equals 1. Okay, 3/5 squared, that's just 9 over 25. So I've got 9 over 25 plus sine squared theta equals 1. Well, 1 is just 25 over 25. So if I subtract 9 over 25 from both sides, 25 minus 9, that gives me 16 over 25. So that tells me that sine squared theta is equal to 16 over 25. So if I take the square root of both sides on that, I have sine of theta equals the absolute value of 4 over 5. So that would be positive or negative 4 over 5. Okay. All right. Next up, we've got our opposites theorem. So that says that if I take the cosine of a negative theta value, it's the same thing as having cosine of the positive theta value. If I take a sine of a negative theta, that's the same thing as having negative sine theta, and tangent of negative theta is the same thing as negative tangent theta. I also have the supplements theorem, so that's dealing with supplements of angles. Remember, a supplement is two angles that add up to 180 degrees are supplementary. So 180 degrees is the same as pi. Basically, I'm saying if I take pi minus whatever angle I have, that's going to give me the supplement, and this is what the supplement looks like. So for sine, the supplement is just the sine. For cosine, the supplement is negative cosine. And for tangent, the supplement is negative tangent. So let's suppose that I know that the sine of theta is 0.32, and I want to find the sine of negative theta. Well, I can use my opposites theorem for that. So the sine of negative theta, I know, is negative sine of theta. And I know that's true according to my opposites theorem. Now, I know that the sine of theta is 0.32, so this would just be negative 0.32. Okay, now if I want to find the sine of pi minus theta, I can use my supplements theorem, and I know that the sine of pi minus theta is equal to the sine of theta. And they told me that the sine of theta is just 0.32. So I've got both my answers there. Next up, I've got the complements theorem. So again, supplementary angles are two angles that add up to 180, whereas complementary angles add up to 90. So that's why I've got pi over 2 minus theta. Basically, this is saying the complement of the sine is the cosine, the complement of the cosine is the sine. So if I'm given that the cosine of theta equals p, I want to find the cosine of pi minus theta. So for that one, I'm going to be using my supplements theorem. And if I look back up here, cosine of pi minus theta is equal to negative cosine. Okay, and then I know that the cosine of theta equals p, so this would be negative p. And that was according to the supplements theorem. If I want to find the sine of pi over 2 minus theta, for this one I'm going to be using the complements theorem. And it says that the sine of pi over 2 minus theta is equal to the cosine of theta. And they just told me that the cosine of theta equals p. So that's according to the complements theorem. We also have the half-turn theorem, and that's just saying if I were to turn this 180 degrees, what would happen? So for the cosine function, you would get the negative cosine. For the sine function, you would get the negative sine. And for the tangent, you would just get the tangent, because when you rotate 180 degrees, you get the same exact thing for the tangent. So that's all of your theorems. You don't actually have to, all of your identities. You don't actually have to memorize these because they're all on your formula sheet. You just have to know how to use them. So it's really important to remember that with these identities, if you are thinking about cosine of theta is different than theta. Okay, so if I give you something like, looking back at this first problem here, cosine of theta equals 3/5. That's not the same thing as theta equals 3/5. They're very, very different. Okay, so you cannot just replace theta with that number. You have to replace the whole thing, the cosine of theta, with that number in order for it to be accurate. Okay, so you have to be really careful with these theorems, with these identities. So just make sure that you're using the appropriate identities and you're citing the identities that you used in your proofs. And that's everything for section 4.